Good evening, everyone. Welcome to Mr. Malot's grade 7-8 math class. Today I'm going to be doing an instructional video about the distributive property, where we're going to distribute the number outside the brackets. We're going to multiply it inside to create terms, and then if necessary we will combine like terms as well, which I will go over with you today. I've also got a couple word problems for us to do at the end, so that when we are looking at a word problem, you're able to identify which parts of the question are going to help us get the answer. So let's get started. So when we're doing the distributive property, we usually have an expression like this, where we have a number on the outside, and perhaps we would have variables on the inside or numbers on the inside. And so what we're going to do is we're going to go ahead and we're going to take this number and we're going to distribute it, as the name would imply, into the brackets. Okay, and so what that ends up going to being is we're going to multiply 2 times a and 2 times b, which should give us 2a plus 2b. Now, both of the terms here are different. We have two different variables. We have 2a's and we have 2b's. So we are not able to combine them any further, and we are not able to simplify them either. So that's our very basic beginning here. So for our next question, we're going to add a couple of things in here. So this time we're going to have our 2 on the outside again with our a plus b, and then we're going to have an additional 2b on the outside of the brackets as well. And so just like the last question, we're going to distribute the 2 amongst the a and the b only. We only want to distribute amongst what is inside the brackets. Once we have the plus sign here, that's where we know that we are going to end our distribution. Okay, so we're only distributing from this number and distributing it inside the brackets. So our new expression is going to be 2a plus 2b plus 2b. Now, as you'll notice on this question, different from the last one, is now we're going to have like terms. We have our b's, and then we'll give a little squiggly line there for our a. So the 2a is going to stay the same. It has no like terms, so we'll bring it down. Now we've got our 2b's here. So we have 2b plus 2b, which is going to give us, of course, 4b. And so now, like the previous question, we're not able to simplify that any further, and we're going to leave that here as 2a plus 4b. So what you'll notice is that basically all we're doing is multiplying the number outside the brackets into the terms inside the brackets. And so when you guys get to the next level, when you're going to secondary school, grade 9 and 10, you're going to be doing this distributive property quite a lot, and you're going to have multiple expressions. What they're going to teach you is a little term called FOIL, first, outside, inside, last. And so oftentimes what you'll get, which maybe I can go over later as a little bonus at the end, what something like that would look like for FOIL. But for now, we're just going to kind of keep us more on the basic side here at the grade 7-8 level, introducing the idea and the concept. So here we go on a third question here. We're going to have, this time we're going to have 3 terms in the bracket. So we're going to have 2, and we're going to distribute it to a plus 3b and minus b as well. Okay? And now what I want you to know is that when we are multiplying these, what's really important is that we notice the symbol before each number. Okay, you'll notice a doesn't have a symbol. Typically when there is no symbol, that's going to be a positive a. And so what we're going to end up doing, we'll distribute this in this time. We have 3 terms to distribute, so we're going to get a little rainbow action going, and we're going to distribute to all 3. So our next line is going to look like 2a plus 6b, because we're going to multiply that 2 times the 3, going to give us 6, so we now have 6b's. And now we've got the negative b, so when we multiply 2 times b, we're actually going to have that negative 2 times b, so we'll get the minus in there as well. And so what's interesting about all 3 of these questions is that we actually end up with similar answers. Between b and c, the answers are going to end up being the same. We do have the same like terms again here with our 2b values. So 2a is going to come back by itself and just hang out. And then we're going to have our 6b minus 2b, and that's going to end us with 4b. And so for this skill, you really is going to be just kind of getting those repetitions and repeating this process and making sure that we have the skill really down pat. Especially when you get into the test writing mode, you're just going to want to have this in your mind. You're going to want to have it like mental math. You're not going to want to think about it. You're just going to want to look at it and be able to say, hey, I know how to do that. So let's go on to a fourth question, and then I've got a couple of other ones for us as well where we're going to group some like terms. So let's go for the next one here. We got 3, and we're going to multiply 2a plus 3. Okay, so just like our other questions, we're going to do the same. We're going to have 6a now, because 3 times 2 is 6. And then we have 3 times positive 3 here, which is going to give us a plus 9. Okay, and now on this question, we have one term with a variable here. We have our 6a, and then we have our 9. So those are not like terms, because one has a variable with it and one does not. Okay, you'll notice in our other questions we had 2 a's and 4 b's, so we know a's and b's are not the same. And so when we have a number just by itself with no variables, that is also not the same as a number that is accompanied by a variable. So we cannot simplify this any further. We're just going to leave that just the way it is. So here we go on to number 5. And so as you'll notice, each question is just going to get that little bit extra. So here on our next question, we're gonna add a little bit more. Okay, so our first question, we had 2a plus b in the brackets. Now this time we're going to add another 3 times a plus b in the brackets. Okay, and so now we have this plus symbol here, and so that's going to tell us that we are only going to distribute in front of the plus sign here. Okay, and then this 3 now is going to distribute to the letters over here. Okay, so what we don't want to do is we don't want to make that mistake of saying, oh, we're going to multiply 2 by all of the variables, right? This is a mistake we don't want to make. Okay, we are looking for just the terms in front of the addition sign here in this particular scenario. Okay, when you guys get to the next level, there will be some more challenging questions, and maybe again at the end we can do a little bonus and we can go over a little bit of that advanced thing, in case any of you are wondering. So let's go ahead and execute this one. So we'll go with 2a plus 2b, and now this plus sign is is just here in limbo, so we're going to bring it down, and that's going to act and just be part of our equation this time. Now we'll go and distribute the other side, and we'll have a 3a plus 3b. And so now you'll notice we have like terms, so maybe this time we can do squares over our a's, and I'll do triangles over our b's, just so that we can see visually how those terms are different. Okay, and so now what we're going to get to do is we're going to get to group them all together. So luckily with this one, everything is a positive number, so we won't have to mess with any integers. And so we're going to have a positive 2a and a positive 3a, so in total we've got 5 a's. Okay, and now we also have, in total, we have 2 b's here and 3 b's here, so in total we're going to have 5 b's. Okay, and now at the end of the day here, we're going to have that 5a and 5b, which are not like terms, so we are not able to combine those together. Okay, and we'll do one last one here. This one may seem like a little bit of a rewind, but let's go for it anyway. We have got 10 outside the brackets this time, and we've got an a minus b. Okay, and so we're just going to follow those same rules now with our number 10. We've got an a with no symbol in front, so we're going to say that's positive, and we've got our b here, and it's grouped together with our negative symbol. So we're going to have 10a, the positive version, minus 10b. And since these are not like terms again, that is the most simplified form, and we are able to finish our question there. And so what's really important to remember here is just knowing our number facts. Our number families are going to be really important. They're going to help us do these questions really quick, and we're going to be able to get through them really fast and build our confidence in our math skills here. And so another important skill about this distributive property is we are going to end up with a lot of different terms and variables. And so I want to go over really quick one more time, do a couple of questions here to kind of mix in this grouping like terms and the distributive property in the same expression. So let's go ahead and go for that. Let's label this one 2a. That one up here can be 1a. So let's go for 2a here. And so we'll get a little bit more. So let's start here. We'll have 3x plus 5 plus 4x plus 6. So just like before, nice and easy. We've got 3x plus 4x. That's going to give us 7x's in total. And we've got plus 5 and plus 6. So that's going to give us plus 11 in total. And so there's our expression right there, 7x plus 11. So let's go to another one. We'll go to number B. Okay, now here we're going to have another one to practice our distributive here. We've got 4 outside the brackets. We're going to bring this in, and we'll have 4x plus 3. Okay. Now we multiply the 4 by the 3, and we'll get that plus 12. So we got that 4x plus 12. No like terms, so we're going to leave that right there. Now let's throw something a little trickier at us. We got this one. This will be one that might look a little tricky, but what's going to be important is just to remember our like terms. And what's really important with like terms too is that we make the groups and we make it really obvious visually where the groups are and what terms need to be added together. So we've got a bunch of terms here. We've got 9 plus 5b plus 6b minus 7 minus 8b plus 4. Excuse me. So let's go ahead and underline our variables. We only have b as the variable in this particular question, and then we have a bunch of regular numbers that we are also going to want to add together. And what you'll notice is when I'm grouping these things together is we are grouping it with the symbol that comes before it. Okay, that part is really important because it's going to keep all of our numbers in the right positive or negative where we need them to be. So let's go ahead and do our regular numbers first. So we've got a positive 9 minus 7 plus 4. So let's go ahead and execute that. 9 minus 7 is 2, plus 4 is 6. So we'll have 6 plus, and then we'll go to our b terms. So we've got positive 5b plus 6b. That's going to give us 11b in total, and then we're going to minus 8b. That's going to bring us down to 3b right there. Now we've got all of our like terms combined, and we can no longer simplify this because we have a regular number with no variables, and we have a number with variables as well, indicating that there is some unknown in this equation, something that we don't know, something we have to figure out. Or for these particular questions, we just want to practice the skill of distributing and then adding the like terms and then simplifying our answer. So let's throw one here at you now. We're going to combine like terms and we're going to do the distributive property at the same time. And so this is where learning things like BEDMAS is going to be really important. Our order of operations, right? Brackets, exponents, division, multiplication, addition, and subtraction in the order they appear. So when we think about that, the first thing we're going to think about is, let's go to the brackets first. We do have brackets, but when you look inside the brackets, we have two terms that are not alike. We have a 2n and a plus 3, so we cannot combine those terms together. So we are not able to simplify those brackets. Okay, so we can move on to our next one. You'll notice there are no exponents in this question, and there is no division in this question. So we are going to go right over to our multiplication. And so this is where we're going to bring the distributive property in, because we know that when we do distributive property, we're multiplying this number from outside the brackets and they're going in. So let's create a new line here. We're going to have n plus 4 plus 4n, because we have 2 times 2n, so that's going to give us 4 n's in total. And then we're going to have 2 times 3, giving us the plus 6 on the other side. So now you'll notice we've got all of our brackets are eliminated. We've taken care of our multiplication. We've gone through BEDMAS in order. We've made sure everything is good. And now we're able to combine our like terms together. So let's underline the ones with variables. We've got that 4, we got regular n, and we've got 4n. And then here we've got positive 4 and positive 6. So let's go ahead and add those together. So we're going to have positive n plus 4n. Remember, when n is here just by itself with no number, that just means 1, right? 1n. So we're going to take 1n plus 4n. We just don't write it as 1n because it's just n, right? It's just that number. So we're going to end up having that being 5n as our new number, and we'll take our positive 4 plus positive 6 to give us 10. So our new expression is going to be 5n plus 10. Okay, so that's a really important one to remember, that when there is no number, that literally means we're just multiplying by 1. So when you do n times 1, it literally just means n. So that's why in the question we just see n by itself with no number. Okay? And so that's how that is going to go down there. A little quick distributive property, and we are looking at some grouping like terms. So what I'd like to do next, I know I'm running a little bit long on the video, but I did have a couple of word problems here that I wanted to go through just to make sure that we cover a little bit of all the bases here. So we're going to have a word problem. We've got Joseph orders 3 chicken tenders and a hush puppy. He orders, I forgot to write it here, he orders an additional hush puppy as well. Operated with a little bit too much haste writing the question there, but that's okay. So Joseph orders 3 chicken tenders and a hush puppy. Then he gets that additional hush puppy as well on top of that. So we're looking to write 2 equivalent expressions to show the total cost. Okay, so when we read through this, I see 2 things that are really important. We see this item right here, chicken tenders, and we have another item, the hush puppy, and so that's going to be really important. So we're going to signify these with variables, okay? So what we're actually going to do, since they're purchasing something, it's going to be a price, right? It's going to cost something. So we are going to say the cost of each chicken tender, 1 chicken tender, is going to be the letter C. And our hush puppies are going to take the variable H. Okay? Actually, let's keep that. When we're in math here, we're going to keep it in lowercase. Okay, so let's do lowercase c and h there. Okay, now let's look at his order really quick so we know the total number. So let's go with chicken tenders. He's ordered 3 in total. Okay, so what we're going to end up doing is we're going to have 3 chicken tenders in total times the cost for 1 chicken tender. So we're going to have 3 times C, 3 times the price of each chicken tender. He orders 1 hush puppy as well. Well, I guess that could have stayed. Hush puppy is going to equal H times 1, or 1 times H. Okay? Then the additional is going to give us another H times 1. So in total, when we think about all of the items, we've got 3 chicken tenders in total, and we've got 2 hush puppies in total as well. And so what the question is asking us is, can we write this in 2 different ways? Excuse me. And the answer is, of course we can. So the first way we're going to do this is we're just going to look at how many C's and H's that we have. So the first expression is that we're going to look at this. We're going to say, okay, 3 chicken tenders. We're going to write that 3 times C. Looks just like this in a math question, 3C together. And now we've got 2 orders of hush puppies. So he does order 1, but then he orders the additional 1. So we're going to put that term in here as 2H, 2 times the cost of a single hush puppy. And so that's going to be our first expression there, 2C plus H. Our second expression, we are going to do it a little bit different. It's going to look kind of like our distributive property, where in brackets we're going to split the terms up, where we're going to have 3 times C in one bracket, and we're going to add it together with 2 times H in another bracket as well, to signify that we need to execute the cost of the chicken tenders first and the cost of the hush puppies as well. And then we can, once we have the $2 amounts, the like terms, we can add all the dollar amounts together, and we can figure out the total cost for all of this food. Okay, so let's move on to the next question. We've got Rachel's Cafe. They've made 20 liters of lemonade and 15 gallons of iced tea. During the first hour of lunch, they used 4 liters of lemonade and 3 liters of iced tea. And we're going to try and write 2 equivalent expressions for the number of drink servings they have left. So, to make this expression easier, we're going to assume everything is in liters on this one, okay? So we have everything in the same measurement. Now what you'll notice is that the lemonade or the iced tea, sorry, is in gallons. And so what's going to be important first is that we actually want to change our unit of measurement here. We want to switch gallons into liters so that we can make it much easier, okay? And the way that we're going to do that, we'll start off, we got 15 gallons. And so what we're going to do here is we're going to take the 15, we're going to multiply it by 3.785, which is approximately how many liters are in 1 gallon, okay? And that's going to end up leaving us with 56.775 liters of iced tea. So now we have our two things here. We've got our lemonade at 20 liters and our iced tea at 56.775 liters. Okay, now we have both of our expressions in the same unit of measurement, which is really important. The next part that we're going to go over is looking at the amount that we've used. So if you look during the first hour of lunch, they used 4 liters of lemonade, 3 liters of iced tea. And so what's interesting is when we've looked at the part that they've already used, the iced tea part is already converted, it's already in liters, which is great. So now what we're able to do, let's put our amount used really quick over here. Lemonade is going to equal 4 liters, and iced tea is going to be 3 liters. And so what we can do next is we are going to subtract what we've used from what we already have. So we'll do our 20 minus 4 to get our lemonade being at 16 liters. And we're going to subtract our 56.775 minus the 3 liters of iced tea that we've already used to bring us down to 53.775. 0.775 liters. Okay, now we have our total amount left of each. And so what we now need to find out is the part with the total drinks. Okay, so basically what we want to do is we want to turn this into an expression. We want to make these, what we just did here, we want to turn this into an expression somehow. And so really, we've already done some math here, and what we can do is we can just combine what we've done right here. This is going to be one of the expressions. We're just going to put those two together, right? In brackets, 20 minus 4. And we're going to add the 56.775 minus 3. So that'll be our first expression right there, right? And that pretty much ends up giving us the same answer here with the 16. And then our second expression is actually funny since we've broken this down really nicely. We're going to just put these two numbers into one expression as well. Okay, so our other expression will be 16 plus our 53.775. And so there are our two expressions for how much we have left, how much lemonade, and how much iced tea. Now again, I know we've gone a little bit over, but I did mention something about a little bonus question, and so maybe really quick we can take it to the next level and show you a little something about this FOIL thing I was talking about for secondary. And so oftentimes what you'll have is you'll have expressions like this. You'll have 2x, or no, sorry, you'll have two pieces of distributive property here in the brackets. So let's say we have x's. Let's say this one's minus 3. Okay, and so what ends up happening when we have an expression that looks like this, we are also going to use the distributive property to figure out what the answer is. And so this is where FOIL is going to come into play. And this is where this is that first outside, inside, and last. Okay, and so what that means, we're going to take this x, we're going to multiply these this way. Okay, so we're going to take that first number, we're going to multiply it by the inside number, and the last one. Then we're going to take this here, we're going to distribute this way, like that. Okay, and so what that's going to give us is that when we get x times x, this is like when we're multiplying for area. And so because the unit of measurement in area is centimeters, let's say, so when you multiply centimeters and centimeters, you get centimeters squared. Just like in this scenario, when you multiply x times x, we're going to get x squared. Okay, and then we're going to have a minus x times 3, x times negative 3. So we're going to have minus 3x. And now we'll move on to our number 4, where we'll multiply the 4 into the other side of the brackets as well. And so this will be our plus 4x, right? 4 times x going to give us 4x's. Now we got positive 4 times negative 3 going to give us negative 12. Okay, and now what you'll notice really quick, we could simplify this. We have a set of like terms right here, our x's, and we got a regular number here and a number squared. Okay, so remember when the number is squared too, that's going to be something that is separate from the rest. Okay, so let's bring x squared down. We'll simplify these. We'll get a positive 1x minus 12, because minus 3 plus positive 4 is going to be positive 1. Okay, and so this is going to be our simplified expression using the FOIL method.